Welcome back. Today we're going to look at section 5.2c. Our learning target today is to use the conjugate root theorem to write a polynomial function from its zeros. Doing a quick review from yesterday, it says to write a polynomial function in standard form with 2, -2, and -5 as the roots. And remember, roots and zeros we kind of use interchangeably. So if we have a 0 or root of 2, it came from a factor of x minus 2. And if we had a 0 of -2, it came from a factor of x plus 2. And a 0 of -5 came from a factor of x plus 5. So we always start with our zeros and use them to help us create our factors. Then we want to multiply these together. Easiest thing to do is going to be to put conjugates together first. So we're going to look at these two being multiplied together first. So to find our polynomial p of x, we're going to multiply x minus 2 times x plus 2. We're going to get x squared minus 4, since our middles will drop out. And then we want to multiply that to x plus 5. So we're going to FOIL those together now. So p of x equals x squared times x would be x cubed. Outsides would be x squared times 5, so 5x squared. Insides we'd have -4 times x. And last we'd have -4 times 5, which would be -20. So there's the polynomial that would have zeros at 2, -2, and -5. You could always graph that just to double check that it's hitting the x-axis at those 3 points. So the new idea today is this conjugate root theorem. It says if p of x is a polynomial with rational coefficients, then irrational roots, the ones that have square roots in them, are going to have the form a plus the square root of b. And they always occur in what we call conjugate pairs. So that means if a plus the square root of b is at 0, then a minus the square root of b also has to be one of our zeros or roots. This is also true with our complex roots. If p of x is a polynomial with real coefficients, then complex roots of p of x equaling 0 occur in conjugate pairs. So if a plus bi is one of our zeros or roots, then a minus b is also going to be one of our zeros or roots. So in our next couple examples here, it just says for each of the following, write an additional root that you know would have to be a solution to the polynomial based on this conjugate root theorem. So only irrational ones, things that have that square root symbol on, and imaginary ones are going to have their conjugate. So in our first example, we have a root 2. In our second example, we have a 5i. In our third example, we have a 1 minus root 3. Those are all the ones that are going to have to occur in pairs. The 3 that we see here in this first one does not need its conjugate, right? It's just a nice integer value. We only have to worry about conjugates for irrational ones that have square roots and imaginary ones. So if I have a square root of 2 as one of my zeros or roots, I know that -√2 also has to be one of my zeros. If I have a 5i, I know -5i also has to be one of mine. And if I have 1 minus root 3, I know that I need its conjugate 1 plus root 3. Okay, so notice I only added an extra pair for the ones that were irrational or imaginary. All right, so let's try a couple here. It says write a polynomial with rational coefficients in standard form given the following zeros. Hint, first use the conjugate root theorem to identify the additional root that you need. So again, because we have a square root of 5, we know that we also need a -√5. So we're going to take these zeros and use them to write our factors. So if 0 is one of my answers, I know it came from just a plain x. If the square root of 5 is one of mine, I know that it came from an x minus root 5. And if -√5 is one of my answers, I know it came from an x plus root 5. So when you go from the 0 to the factor, you always have the opposite sign. Now we can multiply these together to find our polynomial. I'm going to hold off on that front x for a minute and put the conjugates together first. So I'm going to look at these two. X minus root 5 times x plus root 5. If I multiply those together, I get x squared. My insides and outsides are going to add up to 0. They're going to cancel out. And then I'm going to have a negative root 5 times positive root 5 would be root 25. But that just simplifies down to be just a 5. So I really have x times x squared minus 5. Now I can multiply those together. So p of x will equal x cubed minus 5x. I just distributed that front x into my x squared minus 5. All right, my second example, notice that I have a 2i. That implies that I also have to have a negative 2i. So looking at my factors from these zeros, the 1 came from an x minus 1. The 2i came from an x minus 2i. And the negative 2i came from an x plus 2i. Okay, again, we're going to put the conjugates together first. So I'm going to hold off on the x minus 1 for a minute and multiply the x minus 2i and the x plus 2i together. Foiling those, I get x squared. Again, insides and outsides cancel. I have a negative 2 times a positive, negative 2i times positive 2i would be negative 4i squared. But remember that I squareds are negative 1s, so this is really just an x squared plus a 4, because negative 4 times negative 1 is positive 4. Now I can FOIL those two things together. So my polynomial p of x, I'm going to have x times x squared, which would be x cubed. Outsides, I get x times 4, so 4x. Insides, negative 1 times x squared, so negative x squared. And last, negative 1 times 4 would be negative 4. Putting this in standard form, we want our degrees to be going from highest to lowest, our powers. So our x cubed would be first. Then we'd have our negative x squared, positive 4x, and negative 4 as our constant. All right, let's try a couple more. Again, we have an irrational 0. This negative square root of 7 implies that we also need a positive square root of 7. So let's go ahead and write our factors out. Our negative 3 would have come from a factor of x plus 3. Our negative root 7 would have come from an x plus root 7. And our positive root 7 would have come from a factor of x minus root 7. Okay, again, we're going to FOIL the conjugates together first. We have x times x would be x squared. Insides, outsides are going to cancel. And our last term would be a square root of 7 times negative root 7 would be negative square root of 49. And that turns into just a 7. So now we can FOIL those two pieces together. So p of x, our final polynomial, x times x squared would be x cubed. Outsides we get negative 7x. Insides we get positive 3x squared. And last term we get 3 times negative 7 or negative 21. Again, we need to put this in standard form. So x cubed plus 3x squared minus 7x minus 21. All right, our next example, we have two zeros that both need to have their conjugate pair. The root 2 implies that we need to have a negative root 2, and the 3i implies that we need to have a negative 3i. So we're actually going to have 4 different factors for this one. The negative root 2 would have come from an x plus root 2. Its conjugate would be x minus root 2. The 3i came from a factor of x minus 3i. And the negative 3i came from a factor of x plus 3i. Again, we're going to put conjugates together first. So I'm going to put those two together. and then I'm going to put those two together. Okay, so my first set, x times x is x squared. Insides, outsides drop out. We get the square root of 2 times negative square root of 2 becomes negative square root of 4. And that would simplify just to be x squared minus 2. For the imaginary parts, multiplying those, we have x squared. Insides, outsides drop out. Negative 3i times 3i would be negative 9i squared. The I squared, remember, is negative 1, so this turns into x squared plus 9. And now if we were to FOIL those out, p of x would equal x squared times x squared, so x to the 4th. Outsides, we would get 9x squared. Insides, we get negative 2x squared. That would total to a 7x squared. And then our last term would be negative 2 times 9, or negative 18. All right, we're going to try one more that has a little bit of an extra challenge to it. We have a 0 of 1 plus root 2, so we are going to have its conjugate 1 minus root 2. So we're going to have 3 zeros, which means 3 factors. The first factor of 0 came from just a plain x. The second factor would have come from an x minus the 0, which was 1 plus root 2. And our third factor would be x minus the 0, which is 1 minus root 2. So these are going to take a little more work to get them multiplied together. Again, we're going to multiply the conjugates first. So we're going to do x times x would be x squared. Outsides, we have x times that. So x times negative, all that stuff in parentheses, would be negative x times 1 minus root 2. We'll come back and simplify that in a minute. Then insides, we're going to have x times that one, so negative x times 1 plus root 2. And then last would be negative times negative, so positive. 1 plus root 2 times 1 minus root 2. All right, we need to clean up some things here. Distributing this x into here, we would have negative x times 1, so negative x. Negative x times negative root 2 would be positive x root 2. Doing the same thing to our next piece, negative x times 1, and negative x times root 2, negative x root 2. And then our last piece, we're multiplying 1 plus root 2 times 1 minus root 2. Those are conjugates. So we're going to have 1 times 1. Insides, outsides will drop out. And we have a root 2 times a negative root 2, so negative root 4. All right, we need to simplify some things. Our negative square root of 4 is really just a negative 2. Notice also that we have a positive x root 2 and a negative x root 2 that are going to drop out when we add those together. We also have some like terms here and here. So combining our like terms, we'd have x squared. A negative x plus another negative x would be negative 2x. And then combining our like terms here, we have a 1 with a negative 2 would be negative 1. And then distributing. So our p of x equals x times x squared, so x cubed, x times negative 2x, negative 2x squared, and then x times negative 1 would be negative x. All right, we're going to use that polynomial to just do a quick review from the last few days. If we were to name it by degree, its highest power is a 3, so we would call it a cubic. If we were to name it by number of terms, we have 1, 2, 3. So 3 terms is called a trinomial. Its end behavior, since it is cubic, it has an odd degree, and its leading coefficient is just a positive 1. So that means it should have kind of a twist like this. So we know that it's going down on the left and it is going up on the right. All right, you can go ahead and pause the video and use your calculator to find the maxes and mins. All right, checking what you have. Your maximum should have been negative 0.22 and 0.11. And then your minimum should be 1.55. And the y-coordinate is negative 2.63. All right, let's do some practice on your 5.2c worksheet.